on the radome. But right now, you can use that 2-foot dish or radome from Pacific Wireless and Hyperlink. There's not currently one available for that bigger dish for the 34 dBi model. MIMO sector antennas, key features is equal beam width for vertical and horizontal polarizations, very low side lobes. There is electrical down tilt. I know Mike will get a lot of questions on this. There is electrical down tilt of 3 degrees built into the antennas, so take that into account when you're mounting those on your towers, that is already built in. They are extremely wideband, 4.9 to 5.9 gigahertz, including the ultra high gain option. We have that available in a 16, 17 dBi model at 5 gigahertz and 19 and 20 dBi as well, and then 2.3 to 2.7 gigahertz at 15, 16 dBi model, both in 90 and 120 sector. Very rugged construction. Again, these are deployed in many different environments, and from a performance standpoint, from a spec standpoint, again, this will rival any $1,000, $1,200 sector antenna as far as the performance goes. So we'll turn the time over to Mike here. We're going to get into, again, this is just a brief highlight. This is something we put into our software as of 5.2 release. We'll get Mike into discussing what the AirView spectrum analysis is used for and some of the key features. So go ahead, Mike.
All right, guys. Ever since version 5.2, we put in our AirViewM software. We originally had our AirView 2 device out, which was our first step in our spectral analyzing software. We felt, at least since I've been here the entire time, which is almost 4 years now with Ubiquiti, that most tools are not available to installers at this time due to the cost. What I mean by that is most of these startup WISPs and generally guys like this who are like mom and pop type operations, they don't have thousands of customers. They can't afford to buy the proper tools to install links in general. So we decided to come out with our own spectral analyzer software, because most of the time these cost between $2,000 and $5,000 for a Cisco type version. But we wanted to bring something free to everybody, any installer who buys our products, at least for the M series gear. So as of 5.2, we put in our AirViewM. What it is, it's with every AirMax product, it allows you to illustrate RF energy as the device sees it, eliminating guesswork for the installation of your devices. What that means is no longer do you just have to go out there and have like an intuition when you install your devices. You can go out there with one of these AirViewM devices, put it up, and actually see what the radio is seeing in terms of interference and other types of carrier signals out there. When you launch AirView, it's a drop-down box in the web UI of all of our AirMax devices. It's going to initially launch with a view that shows 3 different rows of information. The first row is going to be what's called our real-time view. When it pops up, this is just what shows you what's exactly going on at that immediate time. It's hard to show you over a webinar like this. We normally show it in person, but with this real-time view here, you'll see this line jumping up and down as it's detecting different types of RF carrier signals. One thing to note, this detects all RF radiation, not just 802.11 based sources. So it'll help you find if you have like electrical lines and stuff like that, microwaves and that kind of stuff interfering with your devices. The second view you're going to have here is what's called our waveform chart. This is more of an average over time. So instead of having a real-time view, you can look at the waveform chart, and this just measures every second. And the more stuff it detects, it starts changing color, and you'll start seeing waveforms appear in this view. It goes from light blue, which is very little interference, to red, which is heavy interference. Just shows aggregate power of energy collected by the frequency. So it's color-coded, like I said, and then over time it depicts the RF energy signature. You can use that one to determine actual specific types of interference sources once you get used to what each waveform looks like. The third, and what to me is the most important one, is the waterfall chart. This is it shows aggregate power by frequency over time. That just means that every second it's also taking a reading here, and it starts going downwards. And when it detects a carrier, you can see it changing colors. You'll see like yellow, red, and that type of stuff. But what this will show you is intermittent interference sources. So if you have like 30 minutes of no interference, 10 minutes of interference, and then 30 more minutes of no interference, you'll be able to see that specific 10 minutes of interference. It's a very good troubleshooting tool for intermittent interference sources. Just waiting for it to change here. Okay, so you also have another tool that you can open up inside AirView, which is our channel usage chart. This is most important for just 802.11-based installations, because instead of having just the entire RF spectrum, this shows you the specific channels of the 802.11 devices. So in this representation on this chart, you can see how crowded the channels are. If you look to the left where the bars are very high, so which is roughly, it's actually below channel 1, but you can see that those channels are taken up by quite a bit of interference. But if you go into the US channels on the right side, there's very little interference. So when you install your AP, you'd want to put it on that right side of the spectrum to avoid interference. So for remote analysis, AirView, like I said, is launched via the web UI. The one thing to really note about this, once you select AirView, if you do this on your AP, it shuts down the wireless function. So if you had clients connected to it, it would disconnect them because it has to dedicate the entire hardware to doing the spectral analysis. Remote data capture and retrieval is possible. So if you wanted to run this on a remote device where it shuts down the wireless, you can retrieve that information. Once you shut down the AirView, the device will automatically resume normal operation. It means it goes back into AP mode or back into station mode, and your link will come back up and run. So the next slides that we have here are actually my best practices slides. That's another giant question we get asked by all of our users. They're like, Mike, how would you set up your link? It's a tough question because there's a lot of variables that go into it. So what I came up with was a couple slides that just illustrate the basic settings. There's always going to be settings that need to be changed, depending upon the specific installation. So the first solution that we have here is our point-to-multipoint setup. And what I'm going to go through right now is the AP setup. It's very simple. 95% of the time, I would set my links up in AP WDS mode at the AP. And I'll get into that in just a second, why I would do that. But for most point-to-multipoint APs, I'd set them up with a 20 megahertz or lower channel. This helps avoid interference. When you go to that 40 megahertz wide channel, especially with a wide-angle antenna, you present a lot of interference problems to yourself. So I'd say 20 megahertz or below. Always keep the data rates at best or auto. Auto should always be selected, especially if you have legacy clients, ABG clients trying to connect to this AP, because if you lock it to an 11N data rate, you won't be able to connect. Security, WPA, WPA2. Never, ever, ever use WEP encryption. It's garbage. It should not even be included, in my personal opinion. AirMax. In an all AirMax environment, I would say everybody should have it on. And we'll get into the benefits of that in a minute also. But the TDMA is just killer for outdoor networks. So NOAC should always be off from point-to-multipoint because that is a point-to-point protocol. And then AutoAC generally should always be on at the AP.